Hello, my name is Jonathan Bisnet, and this is another short video where I'm going to demonstrate another project on the Edison, and I will include in the description of this video a link to the blog that I've put together that describes this project and how it's all hooked up, but I thought I'd go ahead and at least show you the project. What this particular project is I've included interfaced an ADC, an analog to digital controller, to the Edison. It doesn't have one on board, at least on the mini breakout board. There isn't an onboard ADC. So it's necessary to hook one up. In this case, I actually used a ADC 0804. It's an older ADC. It's 8 bits, so it's not got a ton of resolution to it. And I used another chip, a 74 LVC 245, which I've mentioned on the blog and in other places, to do level shifting between the 5 volts that the ADC is using and the 1.8 volts the Edison is using. And then you'll see here is a potentiometer, which at the moment I'm simply using to set a voltage to the ADC for it to evaluate. Over here are a couple of various transistors and all to control the to drive the controls of the ADC, such as telling it when to convert the data, etc., as well as to have it tell the Edison once a conversion is complete. So that's all covered in the blog and in the schematics on the blog, so I'm not going to go into a lot of great detail here on that stuff. This is more really intended to be a short video just to kind of show you how this is working. And the Edison is sitting back here, as you can see. It's sitting on the mini breakout board, and I brought all of the ports, usable ports, up to the breadboard and have kind of wired everything off of there, so you can kind of make that out, what I've done in there. And then from there it comes out this bank of transistors, and those primarily drive the LCD display. And then, as I showed you, this is the ADC and its logic control circuitry. So if we go back here and look, you'll see at the moment this is reading 78 decimal. We obviously can go 0 to 255. So as I turn the dial here a little bit at a time, you'll see the values changing. The hexadecimal is just simply obviously the hexadecimal representation of the decimal value that's up above. The decimal value is what I'm reading from the ADC. So you can see we move up, get various values here. I don't want to go to 255 just yet, because currently that's how this program is ended. Once it hits 255, the program will actually stop. If I turn it down, we can get all the way down here to 0. Yep. And then we can turn it up just slightly, so you can kind of see that it tracks very well. Anyway, very basic stuff. So if I go ahead and turn it up, once we hit 255, the program will basically end. Yeah, so now when I turn it, nothing happens. Okay, so that ended the first program. So what I'm going to do now is I need to swap a couple of things around here. So let me turn the power off on the board. And I got to pull a few things out. We don't need this ground wire anymore. We can pull this orange wire here for the pot out. And instead, what I want to do is bring in this orange wire, which will be connected to a temperature sensor. This green wire, which is the 0 point for the temperature sensor. Let's get that in there. And then I need this guy here to set a level on everything. So what I've done here is I'm reconfiguring the ADC just a little bit to kind of accomplish a little different feat. how would I best put it? I needed to narrow the range on it. So instead of being 255 or 256, the equivalent, well, let me put it better this way. The millivolts per bit, or the resolution in this case, currently the ADC was running at 5 volts. It's an 8-bit chip, so you were looking at roughly 19.53 millivolts per bit, which was fine when I was using the potentiometer. But now that I'm going to use, in this case, a right here, a temperature sensor, an LM35. It uses 10 millivolts per degree C, which is approximately half of my bit resolution on the ADC, which presents some problems. So what I had to do was a slightly different configuration, which is noted in the schematics and the blog, but I ended up putting a diode in here between ground on the temperature sensor and actual ground to take the ground point on the temperature sensor up to 0.6. And then this other orange wire, which I've got all twisted around in here, let me fix that just a minute. This other orange wire, what it does is take and put that 0.6 volts to the adjustment on the ADC, which is the midpoint for its range. So by getting 0.6 as its midpoint, it thinks its full range is 1.2 volts. You spread that over 256 or 8 bits. Basically now my resolution on my ADC dropped to about 4.38 millivolts per bit. So now it's half of what the temperature sensor is sending in. It gets me at least a little bit better control. It doesn't bounce all over the place like it did before I made that change. So that's an alteration I did based on this ADC to get me a little bit more refinement, get my millivolts per bit smaller. So anyway, I'm going to go ahead, let's power this guy back up. And I go over here and load up the program for this guy, and we should be able to see. Here we go. Put that in there. Run as. All right. So now you can see it's at 21 degrees, 21 degrees Celsius, 69.8 degrees Fahrenheit. And I'm going to go over here and put my finger on the top of this temperature sensor, and you'll be able to watch it start increasing in temperature as it does so. Obviously my body temperature is pulling it up. And once we get it up there, now if I take my finger off, we should be able to watch it start to come back down, drop back to around the 20, gradually drop back to around the 20 degrees C that we had here to start with. It flickers a bit because of the way the LCD does. It's trying to focus on it and realizes it's changing. If I change the angle here a little bit, that might help. So anyway, you're seeing it come back down and almost get back to the original number here. Gets a little bit slower as it gets down here and gets closer and closer to room temperature. Anyway, that's this project. I kind of wanted to give you just a quick feel for what I had done with the ADC and with the temperature sensor. So I would encourage you to go out and review the blog, especially if you're doing something with Edison and you're curious about how. I try to give you as much detail as possible in there on how I did this. So thanks for watching.